Hi, last time we talked about how to look at a box and whiskers plot. Today what I want to do is look at that box and whiskers plot split across two groups and to talk about a few more details. Especially I want to talk about the notion of jittering the data while also showing you some of the options for doing really cool plots. That's my main objective today. So we're going to go to JASP. We're going to go to open up the data library. We're going to go to descriptives, and we're going to get the sleep data, which we got before. I'm going to get rid of what's already there. I'm going to remind you that we have two groups that um, uh, the people got one medication, so that's group one, and another medication, that's group two. It's actually the same 10 people on different at different nights getting the different groups, but we're going to ignore that for right now. And we're looking at the extra hours of sleep they got compared to when they had no drug. Okay, so we're going to go to descriptive statistics, hit descriptive statistics, and now I am going to go ahead and take extra and put it over as the variable that I want to look at. I'm going to take group and split by the groups. I'm going to go to statistics. I'm going to click on median and mode in addition to what was already there. I guess I'll also get the quartiles, so the 25th percentile, 50th percentile, and 75th percentile. But the main thing that I want to do is to show you basic plots and then go to another program. I said basic plots, but I really want to go to customizable plots, because customizable plots is where we have the box plots. I'm going to go to the box plots, and there's our basic box plots. And one of the things that I didn't show you last time was that you can use a color scheme for this. So you can say, I want to use a color palette, and it automatically has a color palette loaded in there. There's a number of color palettes that you can use. This one's called ggplot2, and that's a pretty nice one. So it's giving you two different colors for each of the two different groups. We'll call it drug A and drug B. I want to add in the jitter element. And the jitter element, again, is how you add in a representation of the individual scores. So if you remember, these box plots show you the middle 50% of the data. The whiskers basically take you out up to 1.5 times the interquartile range, which is the width of these boxes. But they end faster if there's no data points that exceed the 1.5 links from the 75th percentile or the 25th percentile going down. Looking at this, we can see that the people getting drug B are sleeping, it looks like a little under 2 hours. Look over here, that's 1.75. If we're focusing on the median as our measure of central tendency, that's about an hour and 45 minutes versus this group, which is sleeping an extra 0.35 hours, which would be 20 or 21 minutes of extra sleep beyond the usual. So these are pretty nice plots. But why are these spread out the way they are? What is this? When I'm looking for individual scores, why am I clicking on jitter element instead of something that says individual scores? Let's find out. Let's go ahead and basically get rid of that analysis. And what I want to do is go back to descriptives and this time go to plot builder. Okay, the plot builder comes up. And this has just a ton of options that you could spend a very long time exploring. And I definitely don't intend to sit here and explore all of that with you. But let's take extra, our dependent variable, and let's put it dependent variable where the y-axis goes. Generally put dependent variables on the y-axis and the group on the x-axis. Okay, nothing shows up, but over here it says individual data points. Aha. So this time, instead of this saying jitter element, it says individual data points. But it's still spread out. And there's these numbers under jitter height and jitter width. Let's figure out what jittering is by getting rid of any jittering. Let's put in 0. When we do this, what we do is we get the data as it truly is exists in our data sets. We move these two windows over, or output or program windows, so that we can see the data window as well. And the data for group is representing simply as 1s and 2s. And now all the data points line up perfectly with the 1s if they're in the 1 group. They line up perfectly with the 2s if they're in the 2 group. And going along the y-axis, they line up perfectly with where they should be represented by these numbers here, which is a little bit harder to track and explain, although there's one number here that's a 2. There it is right there, an exact 2 in group number 1, so you can see that one. Okay, so what is jittering? Now, with a small data set like this, you hardly even need to jitter your data because you can pretty much see all the data points. But the bigger your data set becomes, you start talking about hundreds of data points with only 2 groups, 50 in one group, 50 in the other. A lot of the data points will line up exactly on the same point, and it's hard to see how many data points that you actually have. So what jittering does is it basically knocks the data points off of their center where they're actually supposed to be by some random value, so that just a nudge, so that you can actually make out the different numbers. So for the width, I'm going to go ahead and add back in a 0.3, and now the numbers aren't overlapping as much. Especially this 3 over here, I still have 2 that are overlapping, but I can more clearly see the separation of this 1 from these 2 over here. I can do the same thing with the height. I don't like actually using 0.3 for this because these numbers are already pretty close together, and I don't want a say a 1.9 to go up by 0.3 and exceed the 2. So I'm going to go ahead and make that 0.1. Now the 0.3 comes as a default because if you have sort of whole numbers like 1s and 2s, then if you add a random number of 0.3, that means the numbers, when it says 0.3, it means positive or negative. So that means that you're going to have a random number from a uniform distribution, meaning all the numbers are equally likely that exist between minus 0.3 to positive 0.3, and that gets added on to the number. So a 2 might go up to be a 2.2, or a 2 might go down to be a 1.8. They'll be pretty close to the numbers, but they won't be exactly there. So it's basically adding a random number from a uniform distribution to knock it off of its original spot so that you can see all the data points. That's what jittering is doing, and that's the reason why these data points are kind of scattered out. But they're not so scattered out that you can't see this is group 1 and this is group 2. Let's add just a little bit more to this before we finish up this video. And so that is the notion of jittering. I'm going to go down On a box plot, we'll go over here to distributions, and we'll go ahead and add on a box plot. And you can actually change the transparency of those to like a 0.4. They can see the individual data points and the box plot. There's all kinds of things here that you can play with. If you go on down to themes, colors, and sizes, you notice right here you have a whole bunch of colors. There's seaside, or apple. You can play with that all day and get the types of colors that you want for your graph. I want to also show you that you can take your x-axis, go to the x-axis button, and you can put in drug condition. On the y-axis, you can put in extra hours of sleep. And these numbers actually go from about a -2, -1.6 is about the lowest number I see there, on up to 5.5. So I'm going to say -2 to 6. So -2 to 6. And now you have a pretty nice little graph there. This graph can be extended out. And adjusted so as to give you a really good, nice, clear view, getting you pretty publication ready or presentation ready. That's all my time for today. Thanks for listening. Be back with more.